I'm Matt Greenberg, and today we're going to be talking about the product rule. But first, we have to review our prerequisite skills of the power rule and the chain rule. So to review the power rule, first we must take in the function 2x to the power of 2. Now to get the derivative of this function, f prime of x, we must first look to the coefficient and the exponent of the first function. So to get the coefficient of the derivative, you multiply the coefficient of the first function by the exponent on the variable. So 2 times 2, that would give you 4. You keep the x, and you subtract 1 from the exponent on the first variable. So that would turn x squared into 2 minus 1, which would give you x to the 1, which is just 4x. So therefore, your derivative of 2x to 2 is just 4x. For question B, we have a similar function, f of x equals 5x to the power of 3. And to get the derivative, first we would take the coefficient of the first one times the exponent on the variable. So 5 times 3, multiply together, gives you 15, keep the x, and for the new exponent on the x, you look at the old exponent and subtract 1. So I give you 15x squared, and that's your derivative of 5x cubed. Second review topic, the chain rule, we're going to look at the functions f of x equals 2x minus 1 to the power of 2, and f of x equals 8x squared minus 2x all cubed. Now to tackle the first problem, first we're going to look at what's on outside of the brackets. So right here we can see that there's a coefficient of just a 1. When there's no number here, it's just a coefficient 1. So to find the derivative, first we must look at the exponent on the outside of the brackets times the coefficient by the exponent. That will give us a new coefficient of 2. In brackets, keep the brackets the same, 2x minus 1, and then just like the power rule, you subtract 1 from the exponent. So 2 minus 1 will just give you power of 1, which we can leave blank. Now for the second step, we're going to look inside the brackets. You find the derivative of everything inside the brackets, and for this it is 2 times the invisible exponent 1. 2 times 1 will give you 2 on the outside. And since 1 has no variable, there's no need to add anything else. Now you simplify by timesing the 2 on the outside of the brackets in the middle. That'll give you a new coefficient of 4. Keep the brackets inside the same. And there you have it. The derivative of 2x minus 1 all to the power of 2. Derivative equals 4 in the outside of the brackets, 2x minus 1 inside the brackets. Now for question B, f of x equals 8x squared minus 2x all to the power of 3. So like we did in the first equation, we have an invisible coefficient of 1 on the outside of the brackets. To find our coefficient of the derivative, we must multiply the exponent by that. So we technically just bring down the 3, and then we keep the brackets inside the same just as we did here. That gives you 8x squared minus 2x, and then we work with the exponent. You subtract 3 minus 1 will just give you a new exponent of 2, and there you have your first set. Now we work inside of the brackets. So we must first find the derivative of 8x squared, which is 2 times 8, 16. X squared minus 1 on the exponent will give you x to the 1, which is just 16x. And then since the second term inside the brackets does have a variable, it will not just be 2, you will do the derivative of this. So you minus negative 2 times 1 will give you negative 2. And then on the x, 1 minus 0 will just give you 0, which is to the 1. And there is your second set of brackets. So now for our second line, we come from 16x minus 2 times 1 would just give you negative 2 here. So to simplify this further, we can take out a 2, factor it out of this set of brackets. So here we have taken out a 2, and it leaves you with 8x minus 1. This is equal to this set of brackets because if you multiply in the 2 again, times 8x gives you 16x, and you times the 2 into the negative 1, it will give you negative 2 again. Now for a final line, to simplify it fully, we can look at the 2 numbers over here with no variables on them and multiply those 2 together to give you a new coefficient at the front of 6. And then you keep the brackets the same, x minus 2, x to the power of 2. And then the second set of brackets is the same as your factored form, 8x minus 1. And that's your derivative of 8x squared minus 2x to the power of 3. Now that we have reviewed the chain rule and the power rule, we can start working on the product rule. So take the function f of x equals 3x minus 5 times x squared minus 1. This is like a very long function, very difficult to take the derivative of. However, if we split up into f of x equals p of x times g of x, where p of x is represented by 3x minus 5, and g of x is represented by x squared minus 1, it's very easy to take the derivative of. F of x, the derivative of the entire thing, is equal to p prime of x, which is the derivative of the first, times the original second, plus the original first, p of x, times the derivative of the second, x squared minus 1. Now to put that plan into action, to find the derivative of 3x minus 5 times x squared minus 1, first we would find the derivative of the first, which since we cannot apply chain rule here because it is 1 times 1, the coefficient is 1, we find the derivative of the inside, which is 3x to the power of 1. So we just times 3 times that 1 gives our new coefficient of 3, and we keep the entire original first. So it's 3 times x squared minus 1. And we add that to the original first, 3x minus 5, times the derivative of the second, which is 1 times 2, which gives us 2, and then x squared, the exponent is subtracted by 1, so we still have 1x here. Now in the second line, since we are adding, we cannot just multiply together. We have to first expand into each bracket. So we go 3 times x squared, which gives you 3x squared. 3 times negative 1 equals negative 3. And then you add that all to 2x times 3x, which gives you 6x squared. And negative 5 times 2x equals negative 10x. We simplify that fully, we get 9x squared, which is the sum of 3x squared plus 6x squared, negative 10x, and negative 3. And this is your fully simplified derivative of f of x equals 3x minus 5 times x squared minus 1. Now we have our second problem. F of x equals 2x plus 3 times 1 minus x. We can split each of these up into p of x equals 2x plus 3 and g of x equals 1 minus x. This allows it to be plugged into our f prime of x formula much easier. So here we enter f prime of x equals the derivative of the first, which is just 2 times 1, which we have the coefficient 2, times the entirety of g of x, which equals 1 minus x, plus the entire first, p of x, 2x plus 3, times the derivative of the second, g of x, which is just negative 1 coefficient times the invisible 1, which gives you negative 1 here. Now we enter the second line. We expand these out into the brackets to simplify them. So we have 2 times 1 equals 2. Negative x times 2 equals negative x. And then the addition sign here gets turned into a subtraction because you're just subtracting negative 1 times 2x equals just negative 2x. And then for the final constant, it is just negative 1 times 3, which is just a negative 3. This fully simplified is negative 4x minus 1. However, we can factor out a negative 1 so that way inside the brackets is fully positive and our leading variable is a positive number. Now for a third problem, we have y equals 5x squared minus x plus 1 times x plus 2. So its derivative, dy over dx, can equal the derivative of the first, which is 5 times 2, gives you 10 to the x, minus negative 1 times 1 just gives you negative 1. And since this is a constant with no variable, it just gets dropped. So that gets times by the full original of that, x plus 2. And then you add this to the original of the first, 5x squared minus x plus 1, to the derivative of the second, which is just the invisible one here, times the invisible one here, gives you 1. Now we get into the second line. We expand these brackets out by doing the FOIL rule, first times these two, inside times these two. So that gives you 10x times x, which gives you 10x squared, plus 10x times 2, which gives you 20x, but you subtract this times this, which is just negative 1x. So you end up with 20x, and then you just multiply the two final terms, which are constants. Negative 1 times 2 is just negative 2. And you add that all to 5x squared minus x plus 1, because this entire trinomial times 1 is just this original. Now we can combine like terms, and that gives you a final equation of the derivative dy dx equals 15x squared plus 18x minus 1. So for our third question in our first thinking problem, we must determine an equation for the tangent to the function f of x equals negative x cubed plus 2 times 4x squared minus 3 at the point x equals 3. To solve this, first we must find the derivative of the entire equation, then we plug in our point, x equals 3, into that to find the slope at that point of your original y tangent line. And then finally, we find the x value by plugging in x equals 3 to the original function. And that will give you the line in the form of y equals mx plus b. Step 1, we must first find the derivative of the original equation. Using the product rule, we know we have to find the derivative of the first set of brackets, which in this case is negative 1 times 3, which gives you the coefficient of negative 3, times x to the power of 2, because x cubed minus 1 on the exponent is x squared. You times that by the entire set of brackets, 4x squared minus 3, and that is all added to the original set of the first, negative x cubed plus 2, times the derivative of the second set of brackets. 4x squared gives you the derivative of 8x. So for our second line, we must now expand each of these into the set of brackets and then add them together and simplify. So that gives you negative 3x squared times 4x squared equals negative 12x to the 4. And negative 3x squared times negative 3 gives you positive 9x squared. Now for the second set, it is 8x times negative x cubed, which is resulted in negative 8x to the power of 4, and 2 times 8x, which gives you positive 16x. Now we can simply add like terms together to get our fully simplified equation. F prime of x equals negative 20x to the power of 4, because negative 12x to the power of 4 minus 8x to the power of 4, it gives you negative 20x to the power of 4. Since there's only one term with the variable x squared, we just keep the positive 9x squared, and same goes for the positive 16x. Therefore, your final derivative equals f prime of x negative 20x to the power of 4 plus 9x squared plus 16x. Now we will find the slope of the tangent line at the point x equals 3. To find this, we must first plug in 3 into our f prime of x equation. So here we have f prime of 3 equals negative 20 times 3 to the power of 4 plus 9 times 3 squared plus 16 times 3. This gives you negative 1,620 plus 81 plus 84, and therefore your final equation of f prime of 3 equals negative 1,491. Since we have found the slope of the tangent at x equals 3, we must find the y value at x equals 3. To do this, we simply plug in x equals 3 into the original function. Therefore, f of 3 equals negative 3 to the power of 3 plus 2 times 4 times 3 squared minus 3. This simply gives us negative 25 times 33, which results in a y value at x equals 3 of negative 825. We can substitute in our tangent slope and our y coordinate into y equals mx plus b form to find our vertical shift, which is b. So we plug in y, was what we found of f of 3 equals negative 825 equals our tangent slope, which we found is m, which is negative 1,491 times what we already given, which is the x coordinate, which is 3, plus our variable of b. B is represented by our vertical shift, which we are trying to solve for. So if we just times 1,491 times 3 and bring it over, we get a positive value of b equals
3,648.
And therefore, once we put it in our original tangent form, which is y equals mx plus b, we take out our y value and our x value so that we can sub in whichever point you want, and you get the equation y equals our slope, negative 1,491 times x, plus our vertical shift, which is up 3,684 units. And that gives you the final equation of y equals negative 1,491x plus 3,648. Now that we have finished our knowledge and thinking problems, we can work on a communication application problem. The situation we're looking at is
A store that sells ball caps sold 600 last month for $15 each. If the store increases the price, studies show that for every $1.50 price hike, 30 less caps will be sold. Model this equation. So we know that this is a revenue function, and in a revenue function, it equals the total revenue, price times quantity. So the entire amount of money you make is equal to the price of what you're selling times how many of what you sell. So in this situation, we model as R of n. R is the revenue, the n represents how many caps are sold, and inside of the function it is 15, which is how much the original price was, plus 1.5n. The 1.5 is the amount of money that each price hike is, and the n represents how many price hikes there are. So if there are 3 price hikes, it would be 1.5 times 3, and that would be how much money you add on to the original price of $15. The second set of brackets equals the amount sold. So 600 is the initial amount sold at $15 a piece. But since you're increasing the price, you're selling less caps per month. So that means you are subtracting from the total amount that you sell. 30 is the amount of caps they currently sell per month, or 600 is the amount they currently sell per month, and 30 is how many they will lose for every $1.50 price increase. Therefore, you can model the caps per month by 600 minus 30 times n.
Now that we have found what R of n is, we can look to the derivative. And the question is asking us, what does R prime of n represent in this question? We know that R prime of n is clearly the derivative of the revenue function, but in the context of this particular question, the derivative of the revenue function models the marginal revenue. The marginal revenue represents the rate of change at which the price is changing, and we can use this to find the price change at any instant. Now the question is asking us, determine when R prime of n is equal to 0, and what this means for the store. So first, to find when R prime of n equals 0, we must first find R prime of n. Now to do this, we must find the derivative of the first using the product rule. So we use the derivative of the first, which is 1.5 times the invisible 1 on the n, which gives us 1.5, and then the n gets dropped because 1 minus 1 equals 0. 15 gets dropped because there's no variable, so 0 times 0 equals 0. And we times the derivative, 1.5, times the entire set of second brackets. So that gives us 1.5 times 600 minus 30n. Now we add this to the derivative of the second, which is negative 30, because we get that using the same method, the chain rule. We go 1 times 1 gives us 1, and then we times 1 by the derivative of the inside, which is negative 30 times 1. That gives us negative 30 here, and we times it by the entire set of first brackets, 15 plus 1.5n. Now we can start simplifying. We first expand the coefficients into each of the brackets, and that gives us 900 minus 45n minus 450 minus 45n again. Now we just combine like terms, and that gives us 450, which we got from 900 minus 450, and that is subtracted from 90n. We get the 90n by combining the two negative 45n's. Now we can simplify this even further by factoring out a 90 because it is common in both 450 and negative 90n. This gives us a final derivative of R prime of n equals 90 times inside the brackets 5 minus n. Now that we have our derivative of R prime of n equals 90 times 5 minus n, we can solve and determine when R prime of n equals 0. To do this, we simply sub in 0 for R prime of n, and that gives us 0 equals 90 times 5 minus n. So we are trying to isolate for n. Now once n is isolated for, we know that that will be the x-coordinate, or in the terms of the question, the number of price increases where the local maximum occurs. This local maximum represents the maximum amount of revenue that this company can make. So to do this, we simply divide both sides by 90. 90 divided by 90 equals 1, and 0 divided by 90 just equals 0. So we times the 1 in, which is a common misstep. We just go 1 times 5, 1 times negative n, which gives us 5 minus n. So 0 equals 5 minus n, and we bring over the negative n to make it a positive n, and we see that after 5 price hikes, we will get our turning point and our maximum revenue. So to find out the amount of money which our maximum revenue makes after 5 price hikes, we simply take the 5 and plug it into our original revenue equation. So to find R of 5, we simply put 15 plus 1.5 times 5, that is all multiplied by 600 minus 30 times 5. Now to explain this, it is our original price, $15, plus the amount of money we will increase the cap by. This is $1.50 for every increase and 5 increases. This is the amount of caps we will sell. 600 was our original, and we are subtracting 30 caps per price hike, and we are putting up 5 price hikes. Now we just do the math, and that gives us 22.5 times 600 minus 150, and that gives us R of 5 equals 10,125. In the context of the question, we can determine that after 5 price increases, the store reaches its maximum revenue. The maximum revenue is R of 5 equals $10,125, and we know this because the first set of brackets equals the price of the cap. We know that the price of the cap to reach its maximum revenue will be $22.50. This number right here. Here is the graph of the function R of n. So this is the revenue function versus price increase. On the y-axis we have the revenue, and on the x-axis we have n, which is our number of price increases. Here we can see that this is the same as what we just determined algebraically, because at 0 price increases our revenue is $9,000, and at 5 price increases we can see that is the maximum amount of revenue that this company can possibly make, and it occurs at $10,125 to give you $10,125. Now if we move further to the right, we will see that 20 is where the function reaches the x-axis and its x-intercept. This does not mean that the equation stops here. It just means that any amount of price increases after 20 will mean the company is now losing money. This means that they will have lost so many sales that they cannot cope and that they are in the negatives. We can see visually that 20 is the most price increases they can make while still producing a profit. However, we can also prove this algebraically. To do this, we just take not the entire revenue function, but just the second set of brackets. This is because the second set of brackets, 600 minus 30n, is the quantity. So when the quantity equals 0, we know that the n will be the amount that it took for the equation to get to 0. This is also how we will determine one of the x-intercepts. We are only determining one of the x-intercepts because we know that the other one is on the left of the y-axis, and we cannot occur negative price increases. We are only putting up the price, we are never bringing down the price. So to do that algebraically, we will put 600 minus 30n equals 0, because we are solving for n. We simply move the negative 30n over to the right side of the equation, and that gives us 600 equals positive 30n. We want to isolate n, so we divide both sides by 30 to isolate the n. 600 divided by 30 equals 20. Therefore, our n equals 20, our x-intercept equals 20, and we now know that 20 is the maximum amount of price increases that this company can make while staying in the positive revenue. For the last justification of this graph, we will look at the y-intercept. The reason we're looking at the y-intercept is because we previously explained that we cannot cross to the left of the y-intercept because we can never decrease the price. We are only increasing the price. This means that the initial revenue at R of 0 is the amount of money they would make without increasing the price at all. Now to solve for this algebraically, we substitute R, we solve for what R of 0 would be. So we're not subbing anything into the question, we are just solving for R of 0. Now we are looking at the entire equation for this one. So the revenue of R of 0 is equal to 600 minus 30 times 0 multiplied by 15 plus 1.5 times 0. The reason why these are 0 are because there are no price increases, so the price is not changed, it will stay $15. and there are no caps lost because of price increases, so we will still sell 600 caps. This gives us a simple multiplication, 600 times 15, and therefore you have R of 0 equals 9,000, which is exactly what our graph models.